Hello dear students, my name is Devinder Kaur and you all are welcome to my YouTube channel The Enlightened Room. In this video we are going to discuss about allotropes of carbon. So let's get started. So before discussing about different allotropes of carbon or allotropic forms of carbon, first we should know about what are allotropes. So what are allotropes? My dear students, allotropes are different forms of same element that may possess same physical state, but they all have different physical properties. Okay, allotropes are what? Allotropes are different forms, different physical forms of that same element. For example, we are talking about the allotropes of carbon. So what are we discussing about? Graphite and diamond. Now these two are made of what? Carbon. So these two or more, there could be more than two or more different forms of that element that have identical or same chemical properties, but they have different physical properties. They have what? Different physical properties. Now first we are going to talk about the graphite. Now what is graphite? It is this soft metal, you can say, or soft form of element which is usually used in our pencils, right? The lid of our pencil, the nib of our pencil is made of what? Graphite. Okay. Now what is this graphite and how it is formed, or it is its structure? Well, graphite is naturally found in our environment. We can naturally find it, okay? But the structure of graphite is way more different than that of diamond. And because of that, these two have different physical properties, okay? And today we are going to discuss about it. Now first of all, let's talk about the occurrence. It is naturally found on our earth. It can be easily found and it is cheap because of that, as it is easily found, and it does not need high pressure temperature to form. Okay, so that's the occurrence. Now the basic thing we need to know about it is the structure. First of all, graphite is two-dimensional. It is two-dimensional. It is 2D. Now how it is two-dimensional or 2D? In graphite, each and every carbon is bonded with three other carbons. Now this carbon is bonded with this carbon, and you can say this carbon. Okay, one carbon has been bonded with three carbons. Now these other carbons will be bonded with another three carbons. And what is the valency of carbon? 4. Carbon has the valency of 4. So how many bonds it should make? It should make 4 bonds, definitely. But still one electron is left free here. Remember this point, one electron is left free in each and every carbon. Okay, now how it is 2D, we are going to discuss about it. Now this carbon should be bonding with other two carbons, as it is already bonded with this one carbon. So this carbon is here, it is formed with the other carbon. This one carbon has made bond with this carbon and other carbon. Alright, I am going to place it, this one here. Okay. Now these two carbons again form bonds with another carbon, another two, because it is already bonded with this carbon. Are you getting it? Okay, I am going to repeat it. First of all, let's start with this carbon. The carbon present here has formed bond with another three carbons. 1, 2, 3. Now its purpose of making bonds is done. Now we are not going to talk about it. Now we are not going to touch it. We will talk about these two carbons. Now the above one has already formed one bond with this carbon. So how many bonds does it need to make to another? These two bonds are formed. Same goes with this one. This carbon needs to form two more bonds and it has made two more bonds here. Do not confuse it with the valence electron. Okay, and each and every one has one electron in their valence shell present. Okay, now these two, because we are trying to find its structure, these two will again make another bonds with another two carbons. Okay, so it has made a bond with this carbon, and the same goes with this one, and the other carbon is here. Now if we only consider, let me take a marker, another marker. Now if we consider this structure, what kind of structure you are looking at? Hexagonal. It is hexagonal. 1, 2, 3, 4, 5, 6. It has 6 sides. It is hexagonal. It is basically a benzene ring, you can say. Okay, so it is hexagonal structure, and all this structure forms hexagons like this. Okay, so it forms a layer of hexagons all over. You can say a hexagon has formed here, another hexagon, 1 and 1, 2, 3, 4, 5, 6. Another hexagon has been formed here, 1, 2, 3, 4, 5, 6. Another hexagon. Similarly, a layer of hexagon will be formed, and it will be upper layer. That means there would be one more layer beneath it. Let us say it is the upper layer. Now beneath it would be another layer. Okay, this is another layer. With this layer, another hexagons will be formed. Beneath this would be another layer. Another layer of hexagons will be formed. So what kind of structure it is? Layer structure. What kind of structure does graphite possess? It is layered structure with the help of hexagons, and these layers are sticked with each other, but they are not very strongly bonded with each other. Okay, so the force of attraction, you can say, force of attraction or force of bonding between these two layers is weak, because what kind of forces are acting here? Van der Waals forces. Now for your knowledge, Van der Waals force of attraction are known as the weakest forms or weakest forces of attraction. Okay, so until now we have covered the occurrence, we have covered the forces of attraction, we have covered the structure, we have covered the dimensions of graphite. Now how does this layer structure work? I told you that in our pencils, the front nib or front lid part is made of graphite. So whenever we write with the help of pencil on the paper, let us say it is the bottommost layer. You can see it from here, the bottommost layer here. When I am writing here, this bottommost layer gets washed away. Then another layer is here. Then that will be washed away when we are writing. Then the next layer will be washed away. First layer washed away, second, third. Similarly, infinite layers of it will be washed away while writing. That's why its nib gets smaller, and we need to sharpen it again and again, because its layers gets washed away. Okay, and what more we need to discuss is it is soft. Now graphite is usually found to be soft. Now why it is found to be soft? Well, the reason behind it is the Van der Waals force of attraction and one free electron roaming around in it. Because all the you can say valency has been not fulfilled, it is not completely stable. Okay, and it has weak Van der Waals forces of attraction. That's why it is usually found soft. So we have covered the point. If it is hard or soft, it is soft. Also it has low density. Well, it has the density, but it has low density as compared to diamond, and we will discuss about it. Okay, then is color. What we need to know about color? What is the color of graphite? Blackish gray. The color of graphite is blackish gray. Then is reactivity. Graphite is chemically unreactive. Okay, and then is electrical and thermal conductivity. Well, my dear students, graphite is good conductor of both heat and electricity. Why? Because of the presence of one free electron in it. This one free electron carries the charge. Now, as it is carrying the charge, it allows the passage of current through it, so it becomes a good conductor of electricity. Okay, and along with it, it becomes the good conductor of heat because of that presence of free electron. Okay, so this is all about graphite, and there are various uses of graphite you can learn about. For example, due to its softness, powdered graphite is used either as solid or dry lubricant, or it is mixed with petroleum jelly as a graphite grease. Okay, now graphite is non-volatile, so it can also be used as a lubricant for heavy machinery operating at very high temperature. Another use of graphite is being a good conductor of electricity. Graphite is used for making electrodes for dry cells and electric accessories. The carbon brushes of electric motors are also made up of graphite. So dear students, one more point we need to discuss is arrangement of electrons, and in this case these are arranged in hexagonal order. Okay, now let's talk about the diamond. Well, dear students, in case of diamond, each carbon makes bond with other 4 carbons. Okay, 1, 2, 3, 4. Now these will form again another 4 bonds. Okay, so in this process a tetragonal angle will be formed here. Okay, making a bond length here. The bond length is always 154 picometer, and a tetrahedral angle will be formed here. Okay, so a tetrahedral, you can say atoms are arranged in tetrahedral order. And what is the type of structure here? The type of structure here is network. A network structure is formed by these carbons. Since all the bonds are fully occupied by the other carbons, so it forms a network form structure. A network, complete net is formed. Like a net of tennis, it has vacant spaces, but this one does not have that much vacant spaces. Okay, it completely forms a strong network, and as in this case layers were formed, in this case no layers are formed. A network is formed and it is 3D. Its structure is usually 3-dimensional. A 3-dimensional network is formed. Okay, and another thing is it has very strong forces of attraction among them, and due to that carbon is hard. Carbon is usually hard. It means it is the hardest element or hardest atomic structure until we have discovered. Then it has high density. Of course, it has such a network of atoms around it, so its density is high. What is density? Presence of atoms or presence of molecules in a closed form, strongly attracted form, and this one is found in highly in case of diamond as compared to the graphite. In graphite it is not found highly, so it has high density. It has high density. Apart from that, diamond is bad conductor of electricity. Now why it is bad conductor of electricity? Tell me the reason about it. Why it is bad conductor of electricity? Does it have any free electron? Graphite had free electron in its structure. Every atom of carbon had free electron with it. That means every carbon was possessing some charge, and due to that charge it was able to conduct the electricity. Now is diamond able to conduct electricity? No, it is not able to conduct electricity. Why it is not able to conduct electricity? Because it does not have any charge with it, and it does not have any free electron to conduct electricity, but it is a good thermal conductor. Okay, and due to that reason many drilling tools are made of diamond, as it does not overheat. Actually it has a property that it can possess heat 5 times more than carbon, 5 times more than copper. Sorry about that. Diamond can possess 5 times more heat than copper, and it does not overheat easily. That's why it is used in various machinery and in various drilling tools. Okay. Now is the color. What is the color of diamond? It does not possess any color. It is transparent. Diamond is transparent. Now as it is transparent, my dear students, it reflects as well as refracts the light. Okay, and what is the refractive index? What is the refractive index of carbon? Diamond. Why I am saying carbon again and again? What is the refractive index of diamond? 2.5, which is very high. Okay, so that's why it is also used in various another things. For example, it can also be used by eye surgeons to remove cataract. The sharp edge diamond is used, but it should be used very precisely. Okay, and also due to its reflecting and refraction of light, if it is polished clearly, it is polished properly, it is also used as a stone or gems in jewelry. Okay, now let's talk about the occurrence. When diamond is naturally occurs under our earth, it is formed with high pressure and temperature, that much high pressure temperature that it becomes so much hard and unbroken. Diamond cannot be broken easily. Okay, it needs such a large force to break it. But my dear students, our science and technology has become so advanced that we can synthesize diamond in our laboratories. That's why laboratory diamonds are also formed, and its structure, its physical properties are so similar to natural ones that we can make a comparison of them. We cannot differentiate between them. Okay. Now the other one is reactivity. Well, in case of reactivity, diamond is unreactive. Wait, did I told you that graphite is unreactive? No. Graphite is actually reactive in nature. Graphite reacts very easily, but diamond does not reactive easily. So diamond is unreactive in nature. Apologies for my that mistake. That graphite is reactive and diamond is unreactive. Okay. Next is arrangement of electrons. So what is the arrangement here? It is formed in tetragonal form. Okay, and it has a network like structure. So in these two cases, arrangement of electrons is different. And one more thing, if you are asked why graphite and diamond has different physical properties, the answer is because of different arrangement of electrons. There you will say that graphite forms a layered structure, and in every layer you would see a hexagonal phase, and it is found in 2D shape, 2D form. But in case of diamond, the arrangement of electrons is completely different from graphite, as it forms 3D form, a network like structure where a tetrahedral angle or tetrahedral form is formed in every single unit of it. And that's why the arrangement of electrons in both cases is completely different. Now as these two are different, they have different physical properties. Okay. Now apart from this, one more thing you have in your syllabus is fullerene, which is also known as Buckminster fullerene, which is C60. C60. Now what is C60? Actually 60 carbon atoms form bond with each other. They also form a network like structure, but they actually just in case of diamond, they form a shape like this, right? Tetrahedral shape. In case of graphite, it forms the layers. Layers are formed like the sheets of book, sheets of copy. Layers are formed. First layer, second layer, third layer, fourth layer. As you remove pages, you would remove first page. A first layer of graphite is removed. When we write with pencil, first layer is removed, then second layer is removed, third layer is removed. Okay, these layers cannot be removed easily. Special tools are needed to polish it. But in case of C60, there are neither layers nor the tetrahedral forms. It forms a ball, which is also known as buckyball. Okay, 60 carbon atoms arranged with each other like in the form of a ball, and it is considered as fullerene, known as Buckminster fullerene. And you can say it is a smallest, it is one of those smallest known particles still known, and we are still doing research on it. Okay, we have found many advantages of it, disadvantages of it, and many usefulness of this Buckminster fullerene C60, but we are still researching on it, and that's why I don't think you have so much in your syllabus, and you do not need to focus that much on it. Okay, you just need to remember what is Buckminster fullerene. It is a ball formed by 60 carbon atoms making a network with each other. They have a network form structure, but not in the tetrahedral form. It forms in the buckyball. Okay, so this is up about allotropes of carbon, in which we have today discussed about graphite and diamond. If you want to know more about Buckminster fullerene, I already have a video of it. I will put the link in description of it if you're really interested to know about that. Okay, so this is up for today now. Okay, let's talk about another topic in next video. See you in the next video.